Good afternoon. My name is Girts and I am managing one of the Latvian startups called Eventech. And I have here also my colleague Katrina. We will divide this speech between two of us because we will explain you more about our success story, and I know that some of you have met us before, but we have also something new to tell. So we are, keeping in advancement. We have gone further, and we have some news to tell and show. Let me just copy my presentation. Could be? Šitas? Ah, yeah. Tev ir, ja? And run from Flash. I think I maybe start with history and how it all actually ended up to the company called Eventech. You see, for those who don't know, in Latvia we have so-called local initiative that is named Commercialization Reactor. It operates for almost 4 or 5 years, and it's actually devoted to bring together scientists with new ideas and bring together entrepreneurs who want to become, let's say, managers, owners of the new companies, let's say new high-tech startup companies in Latvia. So, and like 5 years ago, I was one of these new entrepreneurs who just wanted to start some new business, and I went to one of these they call Commercialization Reactor Ignition events, which is happening twice a year, and actually the next one will be on 4th and 5th November, very soon. And on these events I just met some people. I met people who organize all this, this conversation reactor, and then I actually got into the high-tech business as such, because for your understanding, I'm not a scientist, I'm completely entrepreneur. I even don't have a scientific background, but it doesn't matter here, because if you have, brains and you do it with your heart, it's possible. Yeah, but this is an example actually. And yes, and then in 2011, one of Latvian, let's say, ideas or technologies were presented on this commercialization reactor, and the idea was a new digital signal processing and new equipment for very precise event measurement, which means actually it's basically very precise measurement between two, let's say, signals. And this actually was licensed by the new company called Eventech, and this technology was the basis of technology comes from Latvian Institute of Electronics and Computer Sciences, and we signed a license agreement for this technology and established Eventech in 2011. Actually, we were the first case, one of the first cases. I'm not say the first case because maybe, well, we were let's say the first case where the industry actually licensed something from Latvian, let's say, scientific institution. Why I can say that? Because we also didn't know how to do the licensing. No one had any experience before, and we even went around to Riga Technical University, Technology Transfers, and Latvian University. They actually didn't know a thing. They couldn't help us, so we actually just asking some others, decided how we should do it, and then afterwards when we did it, then the Riga Technical University, I know the guy called me and asked me how we did it and what kind of documents we signed. So we actually taught them later from the practice. So yeah, but that's a history a bit about how it's actually began. Let's see what we have here. So we are, let's say, electronics manufacturers, simple word. Yes, and we are manufacturing these kind of units like you see here in pictures. And I'll explain you later where we use them, where we sell it, what we do. So yeah, I already started, so this is a little bit about the history. So we called ourselves Born in Condensation Reactor because this is where we met. This is where scientists met us entrepreneurs, and this is where we established company. So we are less than 3 years old. In December it will be 3 years for us, and we've been advancing quite quickly. I say I will show you later. So and of course we want to we have to say thank you to one of the co-founders of this technology, that he actually led this technology to be commercialized. And this is Yuri Artyk. Unfortunately, he died already 2 years ago, but his legacy remains, and his let's say inventions are complete. We continue to develop those with his colleagues that are also developing this technology further. So here you can see that, like there was in the Lithuanian company's presentations, the research goes back to actually Soviet Union times. So the roots of this technology is very deep. You see more than 30 years, but only in it was in early 2005 or 4 actually the first version of the product or prototype was established. Now this is what you can see here. This is already third version of the same event timer, what we call this instrument. And actually a few weeks ago we actually launched another version, which is now is launched. And I'll maybe explain you later about what exactly it does and why it is important for our customers to have such device. So our team, we are 6 people in general. 3 are management people and 3 are technical engineering people. So and all what we do, these are people, they are also working in the institute, and they are partly working in Eventech. So, and the management, I mean, we have our own roles, so it's about manage company, develop a new business, try to find applications, deal with administrative issues. That's like every company has to do. So, but just for those who don't know, so where these devices are actually used. So the main application for these devices are so-called satellite laser ranging, and we have also in Riga, we have one station. Carlos managed this station, and these devices are used as time interval counting units. So they are actually very precisely counting the time when exactly laser pulse was shot to the satellite and when the reflection came back. So then the station can then calculate the distance between the station and the satellite. Right, Carlos? I think you can confirm that. So yeah, and we actually, in Latvia there's only like one station, and maybe Latvian University, where we can use these devices. So basically 95 are going to export. And just to prove this, this is a map. The red dots is marked those. You can see there are stations all around it. The red dots are those where the event timers are. But this is map only for the event timers that were manufactured by Eventech. For your information, the institute, before we licensed technology, they were already like selling those timers around the world. Some big, actually there are more, but recently we have sold in less than 3 years 35 units, which is quite a lot, because this market is very small and very specific. And one of these devices costs 2,500 euros. And that is a very specific scientific instrument, so you don't sell them in thousands or hundred thousands. And go further. And what we also did, we actually opened doors. We opened many doors as a private company. We opened many doors that were maybe closed. Our institute didn't do it themselves, because we were like a platform, marketing and pushing more into the market this product. So we have now distribution partners in China, and we have manufacturing partners in USA, and there are a lot of institutes and scientific institutions around the world that are now aware that we have and that already have purchased our equipment. But this is like only one side of the story. What I want to tell, okay, we have this, let's say, unique, wonderful product, but the problem from the business point of view is that this product it has very narrow application. It's very niche product, and from business perspective, it's not very interesting, because the market is very small, and we can't sell like more than the market is. Although currently we almost have 50% of the satellite laser ranging market stations has our equipment, but so the limit is very close. And one of the main aims of establishing Eventech, that's why you can see that we have two aims. One, what I explained just was that we are serving existing market, but the other, which is actually more important for us, is that we are searching new applications for device or for this technology. And I will a little bit explain further, and that's where I will also afterwards invite Katrina to tell me more, because I'll explain you why. So what we did, we just started to look like one by one. We started to find another applications where this technology or devices can be used. I have to say it was really challenging and really difficult. First of all, because the device itself was very specific and only built for specific application. But actually we succeed. We are still searching new applications. We don't stop it. We just go on and find someone, okay, and then we go to next one. Or someone, for example, here you can see with pluses and minuses, I'm marking here that which applications were successful and which was not. For example, light detection and ranging, I will tell you later, Katrina will also tell you, these were successful. We actually found a partner, we established another company to develop this specific business lead, and so on. In this fluorescence measurements, we understood, even where in your institute you have one laboratory that deal with it. We bring our scientists here, we also discussed with other experts from around the globe, and we concluded finally that we have limitation in our measurement rate, which is one of the key parameters that is necessary for fluorescence, but our measurement rate is too low for them, so we can't fit. Or in this case also, we understood that we can't make better equipment than existing. From terms of business, don't do that. it's not worth. Only if you have something really 10 times, 100 times better, something unique.
So they have a more accurate measurement?
No.
So,
The accuracy is lower,
Yes.
demanded is lower, not demanded such high accuracy as we go, but our measurement rate is too low.
Okay.
Again, this is different.
Right.
And this is also one good question because in every application that we were researching, completely different, needs and then parameters. And now our parameters in most cases all our parameters do not comply with this application and vice versa. And actually this is also very hard for scientists to understand. Those who are scientists, it's also information for you that usually we come back to scientists and say, well guys, this box you have here, we don't need that. And of course they are already very sad because we say, for example, LiDAR, we don't need such a box, we don't need such high precision, we need this small board which will be integrated into another system and then it's perfect. And we can sell. And then it's another work and discussion with scientists just to convince them that it's really what we need. And this is also actually a very important thing to understand, that usually when you come and you also have your own idea, technology, you think that could be applicable there. But actually when an entrepreneur comes and we start to research, we found something that it maybe can go completely different direction, which also affects, how you made all it, and this is what's happening.
Interrupt as well.
Sure.
You said the research. I suppose that you are meaning not only your company, the three researchers simultaneously working with public finance research institute. You are together, of course.
When I say yes.
Research.
When I say research, it's not like we make research projects. I say research, we research applications, mainly talking with industry, talking with other academics, and then we just try to get the information, show what we have.
Working together with your institute.
Also, yeah, because we can't work without them, because all information we gather from industry, other institutions, we also discuss with them. Then they also make some comments, conclusions, then we can go back, and this is how we understand and find these niches where we can actually apply.
You said nothing about free space optical communication.
Yes, this is also, I will tell you later, this is about grammetry, just a few words. It was interesting because we actually identified this application accidentally. When we institute were sold, before Eventech was established, they sold some devices to one Chinese customer. We have many Chinese customers. I don't know, it just historically happened that China is one of the biggest customers also for Eventech. We're happy about that. And we found out that the guys that we sold our products, they do not use it for satellite laser ranging, but they actually did it for absolute gravimetry with specific free-fall gravimeter model. And a year ago, I think it was a year ago, I actually visited them and met them in China Institute. So this is how we found this application.
Do you deal with picosecond measurements only or with the microseconds also? Do you have some kind of equipment for microseconds?
Sorry, can you just louder?
Do you deal with only picosecond measurements equipment or with the microsecond also?
No, only it is picosecond measurements, yeah. We actually, what we do, we measure distance between two or many pulses with picosecond resolution. Yeah, we can measure, and the maximum at this point is 20 megahertz is the measurement rate.
So the same thing would be done with the microsecond pulses also?
Yeah, the difference between pulses, it can be different.
Because then you can add one new application with in the mass spectrometry. This kind of techniques are very much applicable, and there is a huge, I would say, huge society of people or researchers who are working in the mass spectrometry, and there this kind of equipment is very much needed.
Oh, okay, we can actually talk it later, private, because we, at the very, very beginning, the mass spectrometry was on our list for applications, but maybe we didn't got enough feedback from industry.
But not in the picosecond, because that is only applicable in the mostly in the microsecond region. So,
Oh, yeah, this could be maybe, but I don't know.
but
We can discuss
but in the
it.
previous slide you showed that you are also working for some new, so that's why I read this.
Yeah. About free space optical communications, we also found some people that that said, okay, might be possible. In all these applications, we are talking about our technology as one component of these systems. It's not that we from our electronics can suddenly build a free space optical communication channel, because it also involves all the optics, lasers and stuff like that. But we found something that our technology can give some advantage to this industry. But I'll tell you later what actually happened with this one. So first, one of the success stories, what came out of this LiDAR application, was that we actually found one expert from Canada, and he saw our equipment, our technology. He understood it quite well, and he had been working in LiDAR industry for 20 years or something. More? Approximately. Yeah, and he had some ideas, some concepts of the new 3D terrestrial laser scanner. And actually our technology, because it's actually time of flight for satellite laser ranging, actually this can be applied also for 3D laser scanners, because the principle actually is the same, but because here our advantage was this very high resolution. So, and yes, and we made a business plan. We convinced local investors, and they provided investments, and this company were established to develop these devices. And Katrina will tell you a little bit more about this company, because I'm not involved directly into this. And this is actually an answer to the question about what we found on free space optical. This was very interesting. Actually, last week I just came back from Aberdeen, Scotland, where I was in a conference called Deep Offshore Technology International, actually conference for oil and gas industry. It means somehow it ended up that Eventech is partly involved in the oil and gas industry, although we were basically in space industry. But what we did, we found another partner that we were researching free space optical communications and one of our possible applications. Accidentally again, but of course only thanks to our efforts, we found a guy from San Diego, USA, and we paid him a little bit of money, so he evaluated our technology, and he can suggest some applications. Okay, what he did, he said, okay, guys, maybe your technology is not very good for free space optical communication, but it could be very good for underwater free space optical communication, of which we of course didn't think and didn't knew that kind of thing exists. And what we did, we actually made the same step as we did previously with the spatial initiatives, but in this case we established a joint venture company between Latvian Eventech and a company from USA, because this company had and has the expertise to building such underwater optical free space communication systems. What they do in simple words, for example, if you have remotely operated vehicle in oil and gas industry, for example, offshore rigs, yeah, and they explore around, they have underwater, they really have a huge infrastructure. If they want to extract the oil, and they use a lot of these unmanned underwater vehicles or remotely operated vehicles, and so far they use acoustics or tethers. But with optical communications, for example, we can exclude tethers, so they are more free to, operate around, and we can give them much higher data rate, which is important because they can transfer real-time video to the, let's say, base station or where the operator is.
The lasers, of course.
Yes. And this is actually what is advantage in the oil and gas industry. Such optical communications is not there yet. There are several groups in the world that started developing this excluding us. So we want to be the first one, because if you are the first one in the new market, so you can get the bigger market share. And this is what we do. And we also, this company established like a month ago, or something. This is very recent. So it took some time. It took some time until we draw a business plan, until we again convinced the investor that this might really work. And we convinced, and we established company, and we already, why I went to Scotland, because we want to get straight away with the industry and find the contacts. And we already did.
Sorry, very simple question. What is Google telling when you're putting underwater optical technologies in Google search?
They have a website.
How much response you are getting?
I don't know actually. Maybe I have tried, but I don't remember. But it's not much.
I will try after half an hour.
Yeah, you
They
try it,
have a
yeah.
website, they have a website, so
I guess you will end up on some universities' web pages, because there are some, division structures that develop those. We know in the USA.
This company has a website.
Yes, we have.
Oh,
It should be-
whether you find it otherwise, yeah. Well, 1 month is.
Yeah, but it's of course the website didn't give you much information, because some information we just keep secret because we don't want to share it. The technology information, it's of course not patented and somehow, because what we actually do here, we are now exploring the market, because we know where we have to go. We just need contacts. We will get feedback. First we get feedback from the industry. What are their technical needs? Because what we can do, we know. But it doesn't matter that what you do, what you can build, it doesn't matter if someone needs it or doesn't need it. You can build something but no one needs it. So we will go to industry, ask what they want, and then we will build what they need. And then we will elaborate our intellectual property, and then we will protect it. So we will go, vice versa, we go from the industry demand, and then we build our technology and products.
I was at a workshop which presented this company and others, and the CEO of the company is a former American ambassador who lives in Paris.
Oh yeah, that's also interesting. We are only partly involved in this as Eventech, because we have CEO is from France and Chief Technical Officer is from USA,
San Diego, yeah.
San Diego, but we work completely fine. We had a Skype call yesterday at 10 p.m. even.
Oh, yeah, it's
Because
San
it's
Diego.
big difference, but that's international business. It's okay. Okay, let me finish with, and of course in Eventech we still continue to search some new applications, and we also have some partners somewhere, and we found again new people and discussed some new ideas. So these are some applications that we in progress that we are researching.
On the
If
deep
you-
space optical, it wouldn't be deep space, it'd be, I suppose, orbital, but two
But they
companies.
both also deep.
Yeah, two companies are both looking at launching it's not server farms, they're looking at constellations of processors, okay, that work together as a supercomputer. Okay, they intercommunicate with lasers.
In space?
Yes, in space, yeah.
Ah. Okay, maybe you can provide some
Yeah,
information,
yeah.
because in these applications, if you know someone that deals with these kind of things, we are really welcome if you can share some information so we can discuss
Sure,
it.
no problem.
For example, in time transfer, we were in Paris Observatory. In Paris, they're setting the time standard for France. So we were there. We also showed what we have, and now we are in discussion. So they will rent our timers. We will rent actually our timers so they can test it and see if we can apply it in here.
What is nuclear electronics?
Well, this is also something very new. We found actually partners from Poland, and we found them in ESA Industry Days. It was in June this year, right? Yeah. And they are also developing. They were developing some kind of electronics. And they said that, okay, it seemed that our electronics might be complementary with their electronics into nuclear electronics application. Basically, they are working with CERN, the large collider thing, and they have some projects there. It's called like White Rabbit project, but I don't know in details. I mean, there's so many different, science and technology behind that. But I know that they have sent what they need from us. We have sent what we have. They are now waiting. They want to have some other projects in this CERN, and they are waiting for additional funding, and then we will get in touch and discuss this further. So, yeah, you had a question.
Can you please tell me that how this technology is useful for the gravimetry? In one slide you...
In gravimetry, it is only in absolute gravimetry. They have so-called absolute free-fall gravimetry when they have a sample that they are just dropping, and they are measuring the distance from the sample until it goes down in this some kind of tube or something. And then they just measure distance until it's dropped until the end. So the distance at the end just gets shorter and shorter, and pulses get more and more. And then from these they measure the speed of how this the sample drops, and then they can calculate this gravimetry constant.
Well, there is a big project between European countries and Asian countries. It's called LIGO. Do you know about LIGO? LIGO project?
Once again, what's the name?
LIGO. It's a laser interferometry gravitational wave observatory.
No. I haven't
Actually, this
heard.
is aimed for the measurement of gravitational waves. So this your product might be useful, maybe useful for them.
Yes, we already have reference from those gravimeter people from China, so we also, this is really interesting.
There are many Asian and European countries which are involved in that project.
Yeah. Okay, we can discuss that as well. So,
Actually, how you technically get ready that you are, by this accuracy, you are operating somehow with the 300 gigahertz. What is the technological elements, this transistor which are gating up and close, and how you get that? I understand 3 gigahertz is a big problem, but you are operating 300.
now this you have to, no, we are not operating in gigahertz rate, it's just megahertz, it's 100 megahertz maximum. So, yeah, we are not in gigahertz. That's why I told that we can't fit into this fluorescent measurement because our measurement rate is not high enough. But now we actually have this new project which measurement rate is 3 times higher than the previous version. But still that's not enough.
Still not enough. We may have the answer to that, but that's the technology here.
Yeah.
It's Jan Solomon.
Yeah, we know, we also work with Jan Sounds. Okay, let me finish this, we're running out of time. So, yeah, this is what we've been developing, is the new version that came out recently, new event time. And then we also have, since January this year, we are in the RDF project with the institute. We are developing new compact event timer, which will be actually a board. This only a simple board, but actually almost the same as this. A much smaller, like this side board, which can be easily integrated into other systems, and also can be combined together, because recently we also have a question about can we make 8 to 12 channel timers. This is only have like 2 channels, so, but we can combine these, like put 10 together and make more channels. Yeah, well, yeah, these are challenges. I mean, finding applications, research, and summarize all the data. This is very complex, very time-consuming process, and find the appropriate industry experts, find the right partners, and explain to them. It's very actually complex to explain and make those people understand what exactly we have, because when they do, then it's completely different dialogue. That's important. We are not just simple time interval counter. We can count intervals, but we also can tell exactly at what precise time the interval come, the time the pulse came, and that's what differs us. But many people with whom we talk, they think that we are only simple time interval counters, which is a different category. And yeah, so of course we always looking for additional experts. We're looking for some partners from these industries where we want to grow, and so on. Yeah, so this is it. If you have some questions, you are welcome to approach me a little bit later, or just write an email or phone me. It's fine.